Hello and welcome everyone to my channel Code with Ease. Today we are going to solve another array question as part of the array series, that is triplet sum in an array. So we are given an array of size n and one integer x. So we have to find if there is a triplet in the array which sums up to a given integer x. Now what's a triplet? So this is similar to a question which we have done previously called the two sum, in which we have to find two elements or a pair which is going to add up to a certain number. When we talk of a triplet, means there should be three numbers in the array which should add up to the given integer x. As we can see in this example, this is the array of size 6 and x is equal to 13. So we have to find three numbers from this array which will sum up and be equal to 13. So the triplet in this case is 1, 4 and 8. Adding these three is going to be equal to 13. So our task is to complete this function where we are given the array, the size of the array and the sum x as input. And we have to return true if there is a triplet in the array. Otherwise, we have to return false. Let's look at the time complexity. It is order of n square and the space required is constant. Okay, so let's start with the approach to solving this question. So if we talk of the brute force way of solving this question, how can we do this? Let's say we'll use one for loop for the outermost for loop, which is going to track the first element. Then we can have another for loop which is going to track the next element. And since we need three numbers, so if outer loop is at 1, second loop is at 4, we can have another loop which is going to track the innermost, which is going to be the innermost loop to track the third number of this triplet. So in that, how can we do? Let's say 1 is fixed, 4 is fixed. Then we are going to check if 1 and 4, 1 plus 4, and any of these numbers is going to give me 13 or not. Okay, if not, then we are going to change the position. We are going to have 4, 45, and then we are going to check if 4 plus 45 and any of the numbers are going to give me the required sum. So in this way, we can keep three for loops, and where each for loop is going to keep track of every element of the triplet, and then we can keep on doing the required summation to find out if that is equal to x. So that is the brute force way of doing this. What can be the problem? As most of you would have guessed, the time complexity, right? So in this case, since we have three loops, three of them are traversing the array, so it will be exponential, so it will be n cube. So the time complexity is n cube and we require it to be n square. So we are not going to go with this solution. We have to try to optimize the solution. As I mentioned in the previous question, which is the two sum video, this is an extended version of that problem, where in the previous one we were doing if two numbers are adding up to this given number x. Here, instead of two numbers, we have three numbers. So we are going to derive some part of it from that question and try to extend it. So let's see how we can do that. See, in the previous video, if you guys can recall, if you have not watched it, I'm going to link it up above. So in that, what we were doing is, since we had the time complexity of n, order of n, and also the space was order of n, we were using a hashing technique. And then we were picking each element and then checking if the another element of that pair exists in the hash map. But in this case, we are not supposed to use a hash map because we are told that the space required is constant. So hash map is out of question. If that is the thing, then what we can think of is using a two-pointer technique. So how will that work? Let's say I keep my outermost for loop again still fixed at 1. Okay. And if I have one pointer from here, from 4, and another pointer from here, and if I just make it traverse, the first I pointer is going to traverse forward and this j pointer at the end is going to traverse backward. In that way, by using these two pointers, we can simply make the pointers move and get the two numbers which we require, and then adding those two numbers along with the fixed one that we have, we can get the required sum. Similarly, we can do this for every element. So first we'll fix 1 and then traverse this part of the array using 2 pointers. Then we'll fix at 4 and then we'll traverse rest of the array using the 2 pointers. So how can this help us? Firstly, the number of loops that we are using is now becoming just one loop, like we require order of n. So in one single traversal, not single traversal, you can say like in one big for loop, we can achieve it. And the second part would be, since we are using a two pointer in itself will have one order of n. So order of n within another order of n, on n into n will be n square. So n square is now equal to whatever the time complexity. I'll reiterate, one for loop outside which is traversing every element is having order of n, and since we're using a 2 pointer on the inner part in the inner sub array, which is also traversing the array, that is why another n for that. So n into n is becoming equal to n square. Now, another thing which we have to understand is, since we are using 2 pointer, usually in case of 2 pointers, what happens is we do some kind of a check inside whether a given two numbers like I plus j, whatever it is pointing at, if those two numbers are adding up to certain number or not. If not, we have to take a decision whether we want to move the I pointer forward or we want to move the j pointer backward. In order to take that decision, we need to sort the array. Otherwise, we do not know which one should be moving. In case of an unsorted array, we cannot move these 2 pointers strategically. So if we do it in an unsorted array, basically 2 pointers technique is not going to hold good, because we have to take a decision whether the I pointer has to move forward or the j pointer has to move forward. Hence, the requirement in this case is we have to sort the array. Once we sort the array, then we keep on fixing one element in the outermost for loop and then traverse the rest of the array using the 2 pointer technique. How will the time complexity look like? As I said, order of n squared will be for doing these 2 loops. One will be for the outermost loop and another will be the 2 pointer loop. Also, we are sorting the array. So for sorting, if we use the inbuilt sort method, it is going to give us n log n. So the overall time complexity would be n log n plus n squared. So this amounts to the maximum is n squared. So this is going to be our time complexity. And we are not taking any additional space, so our space is constant. So this is going to be the entire approach for solving this question. So now let's see how do we code for this. So before we start with the code changes, let's do one dry run on this. So for the dry run, I'll take this array itself. Okay, so first thing is we have to sort this. So on sorting, what we get 1, 4, 6, 8, 10 and 45. So first thing is we are going to sort it. After sorting this, now what we'll do is we'll fix the first pointer at 1 and then we'll apply a 2 pointer on rest of it. So when we're applying the 2 pointer, means the left pointer is starting at 4 and the right pointer is at 45. So what is the first thing that we are checking? If 1 plus 4 plus 45, is it equal to 13? Clearly not. But if it is not equal to 13, is it lesser than 13 or is it greater than 13? 1 plus 4 plus 45 is greater than 13. Since it is greater than 13, so we will move this right pointer backwards. So now the right will be at 10 and the left will still be at 4. Now what we will check? 1 plus 4 plus 10, is it equal to 13? So 5 plus 10 is 15. 15 is not equal to 13, but it is greater than 13. So now again my right pointer will come to 8. Now 1 is here, 4 is here and 8. So 1 plus 4 is 5 plus 8 is equal to 13. So now that it is equal to x, exactly equal to x, that's why now we are going to return true. If let's say we didn't find an answer in this part of the array, then we would have changed from 1, we would have changed to 4. Now the outermost for loop would have pointed to 4 and then we would have done the 2 pointer technique on the rest of the array. Similarly, we would have done it, moved it to 6 and then done the 2 pointer technique on the rest of the array. So that is how we are using the 2 pointer technique plus sorting of an array to solve this question. So now let's see how do we write the code for this. So at first we will do the arrays.sort, the inbuilt method to sort this array. So now we have done with the sorting. Now we'll use the for loop. So I equal to 0, I less than, the length is given already, and I plus plus. So this I, wherever I is at, this is going to be the element where we are fixing on. After the left and right pointer is going to be starting after I. So left will be I plus 1 always. And the right pointer will be n minus 1, the last element. Then we are starting with the 2 pointer. So we'll use the while loop. So we'll say where while left is less than right. Okay. Inside this, we are going to do the triplet sum check. Triplet sum check. So what we are going to do, if the array, the element at the ith position plus the element at the left position plus the element at the right position, if these equal the sum, not the sum, the value x. If it is true, then we are going to return true. Okay. If it is not, then we have to do a check. Else if this is lesser than x. If it is lesser than x, then what we are doing? We are only incrementing the left pointer. The right will be where it is. Else, if it is not lesser, not equal, what else it can be? It is greater. So if it is greater, we are just decrementing the right point. That's it. So this is going to happen. This is the entire thing that we are doing on the sub array while we are fixated upon the ith element. If this runs, nothing comes out of it, then I becomes 1 and the same thing happens. So now let's say this condition what we have written over here for the triplet sum check, let's say it never turns out to be true. If that's the case, then what we have to do is we have to return false. So outside of this for loop, we are going to return false. If this condition is never true, then it will come outside of this for loop and it will return false. So that's about this. So let's try to compile and run. Okay, so I'll submit. Okay. So that's about this question, triplet sum in an array. Do let me know in the comments below if you have any questions or any suggestions. And please don't forget to subscribe to my channel in order to be updated about further content like this. And please do like and share this video. Thank you so much for watching this video.